Okay. Let's take a look here. You guys are doing really, really well, by the way. I mean, considering we've talked about this for less than like 30 minutes, this is, you guys doing pretty good. This isn't like crazy difficult. It's just very different from anything you've ever done. So it's like, what the shit? So, what goes in the middle for z-scores? 0. So 1.51 is right there. And then one's less than that, so there I shade it. So that's smart to do that. It's a z-score already, so I can just look up 1.51. 1.51. And I get 9,345. Done. Because it didn't ask me grade it. The chart gives me areas below. This question wanted the area below. Sweet. Okay. Everybody go with that? Okay. So here we got 0 again. There's negative 0.96. And now I want greater. So if I do look up negative 0.96, negative 0.96, looks to be right there, 0.1685. That's here. The minute you look up a z-score, you just plop that what you get below it. Why? Because that's the way the chart's made, right? That's why there's only one piece of paper. If they wanted more, you'd have volume 1 of z-scores. No, so they made it very simple, and then we have to adjust things when we need to. We're like, ah, shit, that's not what I want. So you do 1 minus, and you get 8315. Now, if you look up positive 0.96, you get the answer immediately. So that's fine. If you don't understand that, just don't ever do it. So here we got, again, 0's in the middle because I still got z-scores. 0's in the middle. And then you got negative 3.21 and positive 1.98. I want this area. What am I eventually going to have to do? Subtract. Whenever I want the area between two z-scores, I never subtract the z-scores. Because what's a z-score tell me?
Distance away from the standard deviation. From the mean.
There it is. The number of standard deviations away from the mean. If I subtract z-scores, I have changed where I am. Then I'll have an answer for a different problem. Maybe you get that problem right, but you lose points for this one. You only ever subtract areas. It's going to become important on the next thing down to number 4. So when you look up 1.98, you get what? Well, and then when you look up negative 321, yeah, there's my kind of bargain basement James Bond. So now if you subtract those, what do you get? 97.54. So there's about 97.5% of data is between these two z-scores in the normal curve. I like it. And that makes sense because we went way far down and pretty far up. So there should be a huge chunk of it in there. Alright, here's the first freaky ass one. So watch. This is a little screw it. I'll do it later. This is the reverse of these. Because here I end up with an area, a percentage. Here I start with a percentage. So I already discussed why it's down here. It's only 33%, and this is half, so it's got to be down there. So it's got to be a negative z-score. So if I look up 0.33, I get it exactly. It's not always going to be exact. You just get close, the closest one. But this is freaking right on it. So it's negative 0.44. That's the z-score. So really what that question is asking is what z-score would give you 0.33 if you looked it up? That's what that's saying. So of course I would just look up 0.33 in the middle and I go, oh, that would give it to me because that's where it goes. Maybe? Sort of? Most of you guys are like, don't give them shit. I'm not going to give them anything to work. Okay. It says 5% above it. So where's it going to be?
Above it.
5% above it. So it's going to be way the shit up here. Chart don't understand this. Chart understands this. Are you with me? So if I look up 0.95 in the body, because that's an area, notice how I write areas up and I write z-scores down. Why are you very careful about that? Because these look like z-scores, don't they? Evil. So 0.95, you get something really interesting. You split the difference here, see that? 95 is right in the middle, so then you go down, 1.645. That's in between 1.64 and 1.65. It's 1.645. Split the difference. Split the difference, this my seventh puberty. We're going to see that number a lot later. All right, so number 4 is just like number 1. It's just you got to make a z-score out of things first. So what goes in the middle here?
0. 31.64.
And underneath that I could put 0. Where's 27.2? Down here somewhere. And then one's less than that. So it should be a relatively small percentage, right? I don't know if my scale's good, but oh well. So to make this a z-score is x minus the mean divided by the standard deviation. So what do you guys get for that?
Negative 0.57.
Yeah, negative 0.57. So now it's just like these problems. If I look up negative 0.57, I get 2843. So 28, almost a 28.5% chance that it takes somebody less than 27.2 total minutes in a week to find the parking spot. If we're doing intersections, it's got to be easier, right? I love you guys. You're like, don't react to anything. Okay. So more than 53, 31.64 is the mean, so it goes in the middle. There's 53, way the shit up there. I want more than, so this is going to be another tiny answer. Make the z-score. What do you guys get for the z-score there? 2.73?
Yeah.
So when you look up 2.73, you're going to get this. I'm not talking to those of you that do the shortcuts. 2.73, 0.9968. So then what's the answer? 0032. All right. And this is the long answer. So maybe somebody can help me truncate this a bit. What's that z-score for 15.5?
2.06.
What is it?
2.06.
206? 07? And what about for 19.5? 1.55? And then you look up the areas for those. So for 207, you get what? 192. And for negative 155, you get 0606. So when you subtract those, you get 0.0. 4, 1, 4. Okay. Oh my God. Okay.
Can you scoot over to the first one again? I missed like a detail on there, I think.
That one, you mean?
Yeah, that very first. Okay.
All right, so here we got 14th percentile. Where's it going to be? To the left. Because there's only 14% in there. So now here's the thing I could say. look at these problems here real quick. I wanted to let us out early. I guess I still will. You see how I'm given an x-score. What do I do with that x-score? I make it into a z-score. And then what do I do with that z-score? I look up a percentage. So this problem, I'm given a percentage. So then I look up the z-score and then I convert it back to an x-score. Just do that process backwards. Math can go both ways. Don't judge, be jealous. So what do you get when you look up 0.14? What z-score do you get?
0.5556.
Yeah, so close as I can get to 1.4. Hey, look, there's Columbus. Close as I can get to 1.4. It's 1.401. That's really close. So negative 1.08. So z is negative 1.08. Get out of there. Yeah. So then how do I get the raw score? The time is I got to get back to x. So I can just use this backwards z-score formula, the guy, right? So x will be 31.64, that's the mean, minus 1.08 times 7.81. Why does this formula make so much sense? Because the answer is 1.08 standard deviations below the mean. That's exactly what that says to do. And what do you guys get? 20 something or other minutes. Woo! We did good. We did a lot. Holy shit. Yes. Certain.
So you looked at that 0.14, right, on the chart?
Yes.
And where'd you get that number there from?
Because what is 0.14?
21.
What is it? It's an area, so it's going to be the body of the chart.
Yeah, I was just trying to figure out what it was.
So I know it's down there, so I know it's going to be a negative z-score. Then you find 0.14 here, and it's close to 0.14.